I'm recording. Go ahead.
You're recording. Let me share my Linux VM here. Okay, here we go. So we're going to go to command injection and ed102 command injection. Inside here, you'll see that there is a ping form. The form below lets us send pings to a remote host. Unfortunately, it has a vulnerability. So normally the way you would use this form is you would type in an IP address. So for this case, we're going to use the loopback address. So 127.0.0.1. So the server is going to ping itself. We're going to click the send pings button. And there, we got our output. And this looks familiar. This is the output from the standard Linux ping command. Well, now here we go. This is good news for us as attackers, because what this means is that the developer is piping our information to the Linux command line, and that is amazing. So let's do a little bit more digging. Let's try to append another command after our ping command. So if we add a semicolon and ls, we should get a directory listing after we ping. Let's see if that works. There we go. So what happened is we pinged the host, and then somehow we got a directory listing. And for those who might be new to the Linux command line, ls is the same as dir in Windows. It gives us the listing of the current directory. So let's see what's going on in a little bit more detail. So I recreated this bug in bash in a file I called pingy.sh. So if we read that file out, cat pingy.sh, you'll see what's going on. I asked the user supplies a variable here. Let me make this a little bigger. So the user supplies a variable here, and the computer runs ping. -c means only ping once, and whatever the user inputted. So if the user inputs, let's say, pingy.sh 127, just like we did on the website, it sends this one here becomes 127.0.0.1. That is what is executed. So it's essentially the same thing as running ping-g 127.0.0.1. And we can verify that by typing it in manually. And yeah, we get the same output. However, if we add a semicolon, so what a semicolon does in Linux is it appends two commands together. So let me clear the screen. Let's say we want to ping ourselves just like before and do a directory listing. So we do a semicolon. So end that command, new command, ls. Let's do -c1 so we don't ping a million times. There we go. So that's how you append two commands together in Linux. So what's happening is the developer thought, well, I'm asking for an IP address, and that's what I'm going to get. They were not thinking that users would be supplying extra bash command line items to run more commands. And so one of the things I love about command injection is you can kind of get in the head of the programmer and understand why that vulnerability exists. So here we're going to have some challenges. We have to find some flags. So ed102.1 says we have to find flag 1. So let's do it together. So if we do the same command 127.0.0.1 semicolon ls, we should see that there is a flag in this directory. There it is. We see this flag. Now we have to read this flag. So the command in Linux to read a file is cat to catenate flag1.txt. So we're gonna ping ourselves, then do a directory listing, semicolon, and then read that flag. And we should get the answer for ed102.1. And let's see. There we go. There's our flag. And so there's a bunch more flags to find here. They're hidden in different subdirectories that they're a little harder to find. And one trap for new players is that this input box does do some sanitization, meaning it takes away certain characters that might be an issue. So the characters in particular are forward slashes. So if I add a bunch of forward slashes here, you'll see that at the top of the form, the raw input was 127.0.0.1, forward slash, forward slash, forward slash, but all those forward slashes get taken away. So you have to be very clever to figure out if something is in a subdirectory, how do you read from those subdirectories? And just another tip, if you want an easy way to find all the flags, I want to recommend using the find command in Linux, find dot forward slash, or just find dot, I should say. We'll show you where all the flags are right away. And now you have to figure out how to get all those flags. So here we have flag 1 again. There's flag 2, flag 4, flag 3. Yes. So you just have to figure out how to get past the sanitization. So next up, we have a very famous bug in a program called ImageMagick. So what ImageMagick does, it's a command line program that lets you manipulate images. And the bug here is that the idea was you could supply image data and then have it edited on the fly. So for example, let's say you wanted to upload a icon file, but then you wanted the background to change. And you can supply these commands to ImageMagick. However, there was a bug in the way that ImageMagick worked, in the way that it called a command in Linux called curl. And that allows us to inject commands right again into the bash command line using a real program that is quite vulnerable. So in order to do this, we're going to create a fake JPEG image, an exploitable JPEG image. Luckily, we have the template right here below. So we're going to copy this text here where it says push graphic context, view box, 00, 640, 40, et cetera, et cetera. We're going to copy all this. We're going to go into our favorite editor. Let's just say it's Nano for now. And we're going to make a file called exploit.jpg. We're going to paste in that template. And here, where I'm highlighting echo hello date, is where the magic happens. This is where we are going to have the bash command line, the Linux command line, say hello, and then print out the date when we upload our malicious image file. So we'll do Control X to exit. Save modified buffer, we're going to push Y for yes, and then enter, because we're going to write to exploit.jpg. So now our exploit's ready. We're going to open up our browser, click the Browse button, find our exploit.jpg, click Open, upload the image, and let's see, we should have somewhere, oh, there it is, right down here. Remember we said we're going to echo hello and print out the date? Haha, there we go. Now we have hello and the date. So we were able to successfully inject Linux command line commands through an image upload. And like I said, this is a real vulnerability that existed in ImageMagick for a long time. So we have some challenges. We're going to find flag 5 inside a file. So let's do the first challenge, and then you can do the second challenge yourself. So the first thing we have to do is we have to find that file. So we're going to go back here to our text editor. We're going to edit this to, instead of just printing out the date, we're going to try to find stuff. So let's run the find command and see what we find in our subdirectory here. So we will, once again, exit, say buffer, yes, enter. Open up the file that we saved, upload the image, and now we have a bunch of data here. And now sometimes, because of the way that we're combining Linux output with HTML, it's not going to be formatted correctly. A pro tip is to view page source, and we should have everything formatted just the way find would look. So here we have some files here. We have upload.php, don't look here.exe, and don't run me.jpg. And as we just saw with our exploit.jpg, just because something's called JPEG does not mean that it is actually a JPEG file. So the file command in Linux will tell us exactly what kind of file a file is without having to depend on the extension. So for example, even though this is called exploit.jpg, running the file command, we see it's actually ASCII text, which of course we know it is because that's what we wrote in it. So let's do that. Let's edit our exploit.jpg file again. And instead of just finding the files, let's run -exec. So we're going to run something with every file found. We're going to run the file command on every file found and see what kind of file it is. So we know what to do with it. So once again, Control X to exit, save, push Y, enter to save. And let's go back to the browser. We'll close down this tab, push back, browse, open up our malicious JPEG file, upload the image, view as source, view page source. And okay, so here we go. We have don't look here.exe is a ASCII text with no line terminators. Okay, well that's interesting. So we should be able to just print out using the cat, because we know this is ASCII text. We should be able to print this out using the Linux cat program. So let's copy this file name here. Don't look here.exe. We're going to once again open up our exploit.jpg file. We are going to now erase our last command and just type cat don't look here.exe. Control X again, save, yes, enter, back to the browser. We're going to go back, browse for our image, open, upload image, and now we have a flag, flag 5, just sitting there. And now we got our first flag. And so there's another flag to find. Oops, if we can go back. So there's another flag to find. Flag 6 appears when you execute a program. And so we already know that that program, because we use the find function with the file program, we know that there's a Python program in that subdirectory. So we have to figure out a way to run it. And finally, we have Drupal command injection. So in April 2018, there was a critical Drupal vulnerability announced or found. And this was pretty big. It basically allowed any user to run bash commands on a Drupal website. And we have a Drupal website ready to go that's vulnerable for us to play with. And that's very nice of Sam to set up for us. However, because this is so well known and there's automatic scanners to find these websites, we have some HTTP basic authentication set up to keep those scanners from ruining this website constantly. You can log in with student1, student1. So if we go to drupal.samsclass.info, we can log in with student1 and student1. There we go. And so here we have, welcome to drupal.samsclass.info. So this is just a default Drupal install that we know is running a vulnerable version of Drupal. And for people that don't know what Drupal is, it's a content management system similar to WordPress. You use it to make your blogs and stuff. So here's what we're going to do. We're going to grab, we need Python and the request library. So let's do that. So we're going to run sudo apt update. So all of our packages are up to date, or at least it knows what the most recent versions of our packages are. And then we're going to install Python Pip and requests, which actually is already installed on the system. So let's see. So we're going to, I'll do it again here just so you can see. So sudo apt install Python Pip -y, yeah. So everything is installed. Now we need the request library. So what the request library does for Python is it makes HTTP requests and HTTPS requests super simple. So we're going to install through pip the Python package manager requests. There we go. We're all set up. Oop, I meant to do that. Now we're going to copy all this code and we're going to paste it into a Python file. So let's open back up our command line here, and we are going to type nano, and let's do drew.py. We're going to paste in that code, and we're going to make a few changes. So we already have the target set up correctly, and all this stuff here doesn't change. However, What should change is yourname.txt. Where you see yourname.txt, you want that to be something new. Every time we run this exploit, we want to put our payload in a new file. If you try to use the same file name over and over again, it's not going to work. So let's use, in this case, I'm going to call it example1.txt. And there's a few other places where we have to change that. So let's change it here too, example1.txt. And example1.txt. So what's happening? So we're making a HTTP request to the vulnerable Drupal website that makes use of the register component. We're going to be writing, here's the magic right here that are of the code that the bash command that we're injecting. We're going to echo a happy face into example1.txt. And then we will check to make sure it's there and if it's exploitable. If something happened, it'll say it's not exploitable. And we should be able to then download example1.txt from the server with our bash output. So let's push X, Control X to exit, save buffer, Y, yes, and enter. So we're going to run Python 2, drew.py. Aha, it worked. We didn't get an error message. So if our exploit worked, we should have the output of bash at this location. So let's copy this URL and paste it right into our browser. Control V. There we go. Aha, there's our happy face. Remember I said that, let me blow this up. Remember I said our bash command was going to print a happy face into a file? That's what we got. We got our happy face. So if we go back to the site here, there's some challenges. We have to find some flags. So let's go back to our exploit here, nano drew.py. And instead of echoing a happy face, let's do something a bit more useful, like running the find command again. Oh, that find command is so useful. We're going to run find // We're going to find everything in the current directory and write that to example2.txt. And we're going to change all our outputs to example2.txt. Because remember what I said, we have to always choose a unique file name for every attack that we do. So do you want to save the buffer? Yes. Enter. We're going to run this again, Python 2 drew.py. And now our results of that find command should be in example2.txt. There we go. So as you can see, we have our output of our find command here. And what we can do is we can look for something like flag, which is not here. So I guess it's somewhere else on the server. That's okay. So I can't work my scroll bar anymore. Uh-oh. I think my browser crashed. Oh, there we go. Oh, okay, that's fine. So what you're going to do is you're going to use those commands again to find flags on the server. You're going to find, let's see, you're going to find flag 7 and flag 8 using running this exploit here. And I think that I will take a break.
Yep,
right?
I'll stop that video and post it up. That's good.
And if anyone has any questions,